Hello and welcome at our ninth meeting with Science News. Today I will tell you about an article on biomimetic materials that caught my interest this week. As you might know, a number of biological materials, especially the hard ones in our bodies and in bodies of other organisms, exhibit interesting hierarchical structures based on a mixture of organic and inorganic components. An example shown here are bones that are made from collagen fibers and hydroxyapatite crystals. In a similar way, uh, teeth are composed again of protein fibers and hydroxyapatite or calcium phosphate inorganic component as well. These biological materials made from composites of organic and inorganic components have of course inspired people and scientists in making new artificial systems such as those shown on this page. And one such system is described in this recently published article from the Advanced Functional Materials journal that looks at the possibilities of using 3D printing together with enzyme-induced biomineralization in producing hierarchical biomimetic materials. In this work, the authors use two different 3D printing techniques. In the first approximation, they use a technique called direct ink writing, where an ink made from acrylamide monomer, silicon nanoparticles containing as well enzymes and further components can be printed and then is subjected to UV light and biomineralization to produce the final composite. A key part of this work was the investigation of the properties of the inks to be used in this printing process to ensure that the printing process proceeds with sufficient quality. It is not only the printing ink properties, but also the printing process that needs to be optimized as the ink properties depend on shear rates and applied pressures, as can be seen in here. In the next stage of this work, the authors studied the process of the biomineralization of their printed objects. The results can be seen here, both in the printing process and in the images. We can see how the biomineralization changes the internal properties and the macroscopic properties of the materials, turning them from soft materials into much harder ones, also from being semi-transparent to being white. In a further iteration of their work, the authors then turned to a different type of 3D printing called the embedded 3D printing technique. This technique allows the fabrication of more complex 3D objects than those that can be prepared using direct ink writing. However, in traditional approaches, the printed objects are too soft and very often collapse under their own weight. The combination of the printing and the biomineralization then results in objects that are hard enough and stiff enough that they can be freeze-standing. The authors then also take note of the fact that a number of biological materials such as mollusk shell exhibit both good tensile and compression properties, and they achieve this by combining hard parts and soft parts in these matrices. They prepare such materials with good tensile and compression materials properties by their technique as well, again by being able to decide which parts will be biomineralized and become hard, and which will remain soft and tensile. In the final iteration of this work, the authors show the ability to produce a replacement of a damaged part of a bone using the techniques that have been demonstrated earlier on in this paper. Overall, this paper presents an interesting new technique for preparing new biomimetical composite materials that are made by 3D printing, followed by biomineralization reactions, and exhibits a promise for further development. Thank you for your attention, and see you again next time.